Alright, here's the screencast for the second part of section 5. So, cotangent. So recall that cotangent is cosine over sine of x. So it's kind of similar to tangent, where cotangent is defined at all points where the denominator is equal to 0, but here we're looking for where sine of x is equal to 0. And so at these points, copy paste, at these points, cotangent of x has vertical asymptotes. So notice that this looks kind of like tangent, except tangent goes off to infinity and down and has its asymptotes here. So what I want you to notice is like, wait, everywhere we had an asymptote for tangent was when we were dividing by 0, with a number divided by 0. When I take the reciprocal of it, I'll have 0 over a number. So anywhere I had a vertical asymptote for tangent is 0 for cotangent. But anywhere I had a 0 for tangent, because I had 0 over number, when I take the reciprocal, I'm having a number over 0, that's where I'll have my vertical asymptotes. So we still have a period of pi, it's just we're going from 0 to pi. We still have a period long that's pi, but instead of starting at negative pi over 2 and going to pi over 2, we're going 0 to pi. So just a reminder, sine and cosine, we're going between 0 and 2 pi. For tangent, we're going from negative pi over 2 to pi over 2. And now for cotangent of x, we're going from 0 to pi. Alright. So to graph the cotangent, solve the inequality. So once again, these should just be the less than symbols. This automatically solves for asymptotes. Graph the asymptotes. Find the midpoint of the period. Plot the center point. The center point is going to be 0 on the x-axis if no vertical shift. Plot the points left and right. It's just like how we were doing it for tangent. So first step we're going to do, we're going to solve for the asymptotes. So I set whatever's inside between 0 and pi. So when I solve for x in the middle, I get negative pi over 2 is less than x, which is less than pi over 2. So I'll draw my first asymptote. And my first asymptote is going to be at negative pi over 2. Alright, let me draw my line. Alright, here's my line. There we go. And then I go 1, 2, 3, fourth over is my other asymptote. So that's going to be pi over 2. Alright, so I solved the inequality. I see my asymptotes are the ends of my inequality. So pi over 2 and negative pi over 2. It just happens that we had a phase shift of pi over 2 over to the left. Normally cotangent goes from 0 to pi. Alright, let me label my other asymptotes as pi over 2. Halfway between is 0. So my center is always 0 because I don't have a vertical shift here. And then let me label my other ones. This is pi over 4, negative pi over 4. So this time, cotangent actually has, if I took cotangent of negative, if I took cotangent of pi over 4, it's positive. So cotangent of pi over 4, that's still going to be root 2 over 2 over root 2 over 2. So this is 1, except the issue is this is cotangent of x plus pi over 2. So I'm not actually, when I plug in a positive pi over 4, I'm taking cotangent of pi over 4 plus pi over 2. So cotangent of 3 pi over 4, as this is 2 pi over 4 plus 1 pi over 4 is 3 pi over 4. Cotangent of 3 pi over 4 is going to be negative 1. So for cotangent, for tangent, we had our middle, we went up 1 to the right 1 and to the left 1, down 1. So tangent look this way. For cotangent, it's flipped. So when we have our center point, we go over left up 1, over right down 1. So I just wanted to like prove it to you guys by plugging in pi over 4 in, and then we see it goes down to -1, and then over left 1, up 1. So the 5 points you're going to have is vertical asymptote, 1, 0, -1, vertical asymptote. These are the 5 things you're graphing. So left to right, it goes in order of 1, 0, -1. So this is what I mean. 1, oh, this is messy, hold on. So I'm just going to look from 0 to pi. I just want to look right here, 0 to pi. So I have my 0 right here. Left is +1, right is -1. So cotangent looks like this. So I had to have it match when I was graphing. To go up and then down. Okay. So that's basically it for cosecant and secant functions. Remember, cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. So sine normally goes. So let's hit up this first one. So this is the graph of sine. So notice that we have points where sine is 0. So anywhere sine is 0 is where I have a vertical asymptote for my cosecant function. Because if I'm taking the reciprocal, you know, if sine of my angle is 0, right, 0 over 1, the reciprocal cosecant of my angle is going to be 1 over 0, which is undefined. So anywhere sine is 0, cosecant has an asymptote. Cosecant has minimum where sine has maxima. Okay, so what the heck this means is, check it out. Right here, sine is at a maximum of 1. But if you look, if I take the reciprocal, this is the minimum for cosecant. So the way I tell people to do this is they graph sine or cosine, and then, based on that graph, anywhere sine had a 0, make that a vertical asymptote. Anywhere sine has a 1 or a -1, that's where you like flip it from. So if I graph sine, something like that, anywhere where it's 0, make a vertical asymptote. Anywhere, so this blue is like what sine of x would be, sine of x. And if I'm wanting cosecant, I see this point is 1 and I flip up. Where it has a minimum, flip down, maximum, flip up. And that's it. That's how I would graph secant and cosecant. You just have to graph cosine and sine first. Okay. So, right here are the actual, like, showing you what the graphs look like without having sine and cosine on there. Notice the period is 2 pi, just like sine and cosine. They have the same period. So, to graph a secant or cosecant function, graph the corresponding sine or cosine function first. Then, draw the asymptotes everywhere the sine or cosine crosses the axis, and then draw the graphs using the minima and the maxima. Okay, so let's see what this will look like. So this first one, use the graph of 2 sine 2x to graph 2 cosecant of 2x. So remember, the period is going to be 2 pi over b. So 2 pi over this b, which is 2, absolute value of 2. So this means the period is just going to be pi. Another way to do this, if I would say, okay, 0 less than equal to 2x less than equal to 2 pi, divide by 2 everywhere. And I'm going from 0 to pi. Alright, so my asymptotes are going to be, so if I'm saying the periods between 0 and pi, which you can see right here, I'm going from 0 to pi. I could list out all of my asymptotes anywhere where sine is 0. Anywhere where this blue graph is 0 is where I'm going to have an asymptote. So at negative pi, at negative pi over 2, 0, pi over 2, pi. Like if you're only going to list 3, I would do the 1, 0, pi over 2, and pi. Since I'm only going to do the, like, you only have to do one period. So at bare minimum, all you would have to do is draw the period from 0 to pi. Because that would be one cycle. So I draw my vertical asymptotes. Okay, good. And then everywhere I have a max for sine, that's my minimum. So I draw the dot at 1 because the reciprocal of 1, right? 1 over 1, take the reciprocal, still 1 over 1. So this is where they touch. And then I just swoopy and follow the asymptotes. Over here, I have a minimum. So I make the dot and then I follow my asymptotes. Okay, that's like bare minimum. This is 1 period. I can go ahead and draw, another period since I have it on my graph as well already. So I connect at this max. I draw the dot because this is the only 1 point you need. So remember how I say you always need 5 things? For here, there are 3 vertical asymptotes, and then there's a min and 1 max, right? So this is where I have a minimum, this is where I have a max, and then these are my 3 vertical asymptotes. Like, that's the only 5 things you need to draw 1 period of cosecant. Okay, so now, last example. First step we want to do is draw out the corresponding reciprocal function. So here I have negative secant of 2x, so I want negative. Reciprocal of secant is cosine of 2x. Okay, so let's draw this first. I'm going to erase this because I don't want these. I got a little too graph happy. So I am going to draw out I'm going to draw this out. Okay, so for cosine, let's see what the period's going to be. So I have 2 pi over absolute value of b, so the b here is 2, because it's a number in front of x. So the period is going to be pi. Another way to do that, let's see, where am I going to be graphing? So divide by 2 everywhere, 0 is less than equal to x, less than equal to pi. So I'm going to go 0 to pi. Alright. So, how many periods do I want to do? Let's have this be 0, 1, 2, 3, 4. This will be 2 pi. Halfway is pi, and this is pi over 2. And 3 pi over 2. Oh, shoot, I forgot. I'm only going to pi, not 2 pi. Hold on. Alright, this is pi. Halfway is pi over 2. And this is pi over 4. 3 pi over 4. And if I go a couple more, I can actually fit more of my graph on here. So the nice thing about sine was we started at 0 and we ended at 0. So that was like my 2 end asymptotes. Cosine starts at a max of 1, so that's not ideal. So if I just extend this out just a couple more, let's see, this is going to be 5 pi, so this is 3 pi over 2. I can just extend it out just a little bit more and it helps. So I have, I've dealt with this whole like scrunching fact, the period, I dealt with by changing the values of my axes, right? I've expanded out, we expanded out my graph. Normally I go by pi over 2, I'm not doing that right now. I'm going by pi over 4. So let's see, that's basically it. So remember, for cosine, we go max, 0, min, 0, max. So let me graph that out first. So we have a max of 1, except, flippy dip, because we have that negative in front. So max 0, 1, negative 1, 1, oops, sorry, 0, 1. Okay, so I multiply all these by negative 1, right? Multiply by negative 1. This changes all the signs, and that takes into account flipping it. So I'm going to start at negative 1, go to 0, go to positive 1, 0, negative 1, 0, max, 0, min, 0, max, 0, min, 0. Okay. So this is what my cosine function looks like. Alright, we see right here, it's like flipped. It's perfect. And I just went like a little bit extra, because whenever cosine has a 0, that's where we're going to have an asymptote. Whenever cosine touches the x-axis, this is where we're going to have a vertical asymptote. So vertical asymptotes are at pi over 4, 3 pi over 4, and at 5 pi over 4. because I want to have like, I need to have 3 asymptotes, and then I'm going to have 2 points. So I'm going to have, right here, cosine has a max. So I just like, it's the same point, and then I just swoop up. That's going to be a min for my secant. And then down here, cosine has a min, so this is my max. So you really only need to have this like 3 vertical asymptotes and your 2 points. But down here, like I could extend it out, but that's like not necessarily needed. All right, so that's it for this screencast.